So far in this class, we have two algorithms to solve differential equations. We've got separation of variables and we've got integrating factor, and this video is going to go over a third algorithm, which is solving what we're going to call exact differential equations. Exact differential equations are in this form where we've got some function of x and y, or maybe t and y here, and then we've got another function that is multiplied by y prime. Now notice these functions really allow anything, e's and sines and cosines, so this is a good algorithm to use for nonlinear differential equations. And whereas integrating factor was a good one for linear. Some of these are separable. We'll look at certain ones that are, but most are not. All right, let's get into the algorithm with an example. And let's solve 9xy minus 9x squared. Okay, sorry for the little glitch here. I'm going to try again. I actually wanted it to be 2xy minus 9x squared plus 2y plus x squared plus 1, and all of that multiplied by y prime equals 0. So notice its form. Right now everything is on one side and we've got 0 on the other. And then we've got this function right here, that would be m, and then we've got this other function in parentheses right here, that would be n. It's multiplied by y prime. So I'm going to do the steps for the algorithm over here, and the first thing we're going to do is pick a psi. That's a psi right there. So that is the Greek letter psi. It kind of looks like a pitchfork. So we're going to pick psi sub x equal to this function m, and we're going to pick psi sub y equal to the function n. Now these are partial derivatives, so if you have not seen partial derivatives yet in Calc 3, then please come talk to me so that we can catch you up on that. All right, so first step for over here, I'm going to pick psi sub x, sorry, that's a psi and not a 4, as 2xy minus 9x squared. And I'm going to pick psi sub y as the function out in front of the y prime, so I'm going to pick it as 2y plus x squared plus 1. In one of the homeworks and in class we're going to go over a little proof, and so that proof will explain why these two partials, why the psi sub y goes with the y prime. In short, it has to do with a product rule and implicit differentiation, where you multiply by the y prime. But we'll explain that a little bit more in detail in class. So the second step here is we're gonna show if this is exact. So what we want to do that is we want to see if we take this partial that we picked, take the m we picked, and take its partial with respect to y, and we want to see if that is equal to the n and its partial with respect to x. Now really, if these are equal, then it means that it's exact, the differential is exact, and we can continue. All right, so here's the second step. We take this psi sub x here that we have up above, and we're going to take the partial with respect to y. And that means that then x is just some constant. So if we have a constant out in front of y, its derivative is 2x, and that means 9x squared is a constant, and derivative of a constant is 0. So now let's take the partial of this other function with respect to x. And so that means that y is constant. So 2y is constant and the derivative is 0. It means x is not constant, so we take its derivative, and it means 1 is constant, derivative of 1 is 0. So these are equal. That means this equation is exact, and we can continue. All right, so the third step, once we know we can continue, is really to find the function psi. So, and that is the whole kind of big picture of this algorithm, is to find this function psi. So in order to do that, we have to do two things. We are going to take the psi sub x and undo that partial derivative by integrating, and so that would be an integral with respect to x to undo that derivative. And then secondly, we need to undo this partial with respect to y. So that means we are going to integrate with respect to y to undo that derivative. All right, so third step here, we are going to integrate our psi sub x. Our psi sub x is 2xy minus 9x squared. And we are going to integrate that with respect to x. And then we also need to integrate the psi sub y, which is 2y plus x squared plus 1 with respect to y. Okay, so back up to this top one here. Now if I'm integrating with respect to x, it means y is a constant. So when I integrate with respect to x, that 2x becomes x squared and y just hangs out. If I integrate 9x squared, then I get an x cubed divided by 3, and 9 divided by 3 is 3. So now this one, if I integrate with respect to y, the integral of 2y would be y squared. The integral of x squared, that's a constant. And if you integrate a constant, you get that constant times the variable. So that would be x squared y. And if I integrate 1, I get y. Fourth and last step is that we are going to combine the two sides, and by combine I mean add together, but don't repeat any terms. So if you look over to the right here, we've got this x squared y and this x squared y. Those are repeating. We're not going to get two of those when we add this together. And then lastly, what we want to do is bring back in that constant from integration. And there's actually another reason this constant appears that we will talk about in class. But the last thing is to set that psi that we get equal to a constant. All right, so fourth step here, we're going to take our integral from this first step, which is the x squared y minus 3x cubed, and we're going to add that to this other integral, y squared, except I don't want to repeat terms, so I'm not going to write down x squared y again, but I do still have a y that's not repeating. I'm going to set it equal to c, and done. All right, and that is the algorithm to solve exact differential equations.